Rational exponents and nth roots. Okay, first thing we're going to start out with is the definition of a rational exponent. The definition of a rational exponent is x to the m over n. So note for just 1 second that rational means a fraction, and that's a fraction that's in the exponent. So x to the m over n is equal to the nth root of x all to the m. So one thing you're going to need to memorize in this concept is that your denominator, which we will call n, is the root of your radical, and m, the numerator, is the exponent on your radical. Okay, before we use that definition, we're going to find indicated nth roots. So this notation I have here with the n and the a can be written as the nth root of a. Okay, so you'll see that in your homework and on your test. So for this first one, it's going to be the fourth root of 625. Now, we've probably memorized some roots like the square root of 9 is 3, the square root of 16 is 4, but to know how we really get the solution to roots, we're going to have to think about what they mean. So what this means is, this problem is saying what to the fourth power is equal to 625. So if you don't know, that's fine, but you need to be able to try and figure it out with a calculator. So take your calculator, do 2 to the 4th, 3 to the 4th, 4 to the 4th. Eventually you're going to find that our answer is 5, because 5 to the 4th equals 625. So a lot of this part might be guess and check if you don't know now, but you'll start being able to kind of just know what the root is. Okay, number 2 is going to be the sixth root of negative 64. So we're trying to figure out what to the sixth power equals negative 64. Now hopefully a red flashing light is going off in your brain right now that you cannot have something to an even power equaling a negative number. If we take something to the sixth power, it has to come out as a positive number because we'll have 6 negative signs that all cancel out with each other because there's an even amount. So this one, for now, is going to be no solution. Okay, number 3. Here we have the third root of negative 64. So again, I have negative 64 going on, but this time it's okay because I can have something to the third power equaling negative 64. Again, if you don't know, test something in your calculator, but our answer here is going to be negative 4. If you test in your calculator negative 4 to the third, just like this with parentheses, then you will get negative 64. Okay, and our last one is the fifth root of 0. Any root of 0 will always be 0 because 0 to the fifth power is equal to 0. So, okay, now we're going to use the definition that we talked about at the start, and we're going to rewrite these expressions in an equivalent radical or exponential form. So, in the definition that we had to begin with, you may want to go up there and label it. I believe I forgot to do this, but we have an exponential form and a radical form. This one is your exponential form, so go back up and label that for me, and this one is your radical form. It's kind of obvious because the exponential form has m and n in the exponent, and the radical form has a radical. Okay, so for this first problem, we are in exponential form for number 5, so we're going to write this as radical form. So, personally, I always memorize that this denominator is my root, so this is going to be the fifth root, and so the 3 is left to go up high, and x is what the base is, because that's what I have as base here. For number 6, 3 is the root, so I have the third root of negative 8 all to the second power. So whenever you're asked just to write it in equivalent form, that's all you do. No simplifying necessary. On number 7, we need to write this as a fraction. Again, I look for that nth root spot, so 7 is going to be the denominator, and 3 will be the numerator. So x to the 3 over 7. Now for 8, if you notice, we don't have a root indicated right here. There's not a number. Any time that I don't have a root there, it's understood to be a 2. So that's a square root. For example, if you took the square root of 9, you would know that that's what squared is 9. So it's just after 2, you start putting that root in there. So this is going to be 25 to the 9 halves. Okay, evaluate the expression without using a calculator. Sorry that that's being blocked, but we'll just have to deal with that. So we're evaluating without a calculator. So what we're going to do is, we don't really know what 4 to the 5 halves is just by looking at that. We need to take that and put it in radical form. So my nth root, it's going to be my second root, so a square root of 4 all to the 5th power. And now I can start simplifying this. The square root of 4 is 2. And 2 to the 5th is 32. For number 10, we have a negative exponent, so what we need to do first is move this whole thing to the bottom of our fraction. So put a 1 on top. It's going to become 9 to the positive 1/2 now. Remember, negative exponents move to the bottom of the fraction, and they become positive. So now I have 1 over, it's going to be the second root, so it's going to be square root of 9 all to the 1st power. I could write it like this, but that's not necessary. It's just the square root. So it's going to be 1/3. Okay, for number 11, we have the cube root of 125 squared. The cube root of 125, if you don't know for sure, just guess and check in your calculator, but the cube root of 125 is 5, and 5 squared is 25. And our last one is 1 to the 7/8. I could put this in radical form, so the 7th root of 1 all to the 8th, but that's not necessary because 1 to any exponent is just 1.
All right, get your calculator and we're going to practice rounding these expressions to the nearest hundredth. So on number 4, you're going to take 4 and raise it to the 2/5 power. And then rounded to the second decimal place, you should get 1.74. Now, on your calculator, you might need to do something like plug in 4 and then use this key, raise to any power, and then you might need to put that your fraction exponent in a parentheses. So open parentheses, 2 divided by 5, close your parentheses. So if you didn't get the right answer at first, try that. Now on number 14, you can think of this in exponent form. So it would be 11 raised to the 4/5 power. And when you put that on your calculator, rounded to hundredths place would be 6.81. So again, you can think of that as 11 raised to the 4/5 power. And on your calculator, you might need to put it in like this. So 11 and then that raised to any power key, open parentheses, 4 divided by 5.
Okay, now we need to simplify radicals with variables. So, if you see here, I've got a few more things going on. This first one, we're going to look at the 36 and the x to the 8 separately. So let's start with the 36. If we just look at this, we know it's the square root if there's not a number there. So the square root of 36 is 6. Now, whenever we take radicals with variables in them, we're just going to think of it again. We can think of it as just dividing. So 8 divided by 2, it would be written as x to the 8 over 2, is just x to the 4th. And we're done. You can write them out individually like this in exponential form if you want to, but you don't need to. You can just say 8 divided by 2. Okay, on this next one, the cube root of y to the 9th, z to the 10th. So for y to the 9th, the cube root of that, we're just going to take 9 divided by 3. So it's going to be y to the 3rd. But z with the 10th, we can't do 10 divided by 3. So what we're going to do is we're going to rewrite this. We can just leave y to the 9th in here. We're going to rewrite it as the next number less than 10 that's divisible by 3. So 10 isn't divisible by 3, but 9 is. So we're going to write it as z to the 9th and then z to the 1. Because z to the 9th times z to the 1 is z to the 10th. So we can simplify this z to the 9th, 9 divided by 3 is 3, and leave this left over z in the radical. Make sure that you carry over the cube root. If you didn't put the cube root there, you would have changed it to a square root, and that's not right. Okay, let's do another one. The 4th root of x to the 8, y to the 3rd, and z to the 13th. So here, the x works out great. 8 divided by 4 is 2, so we're going to have x squared. Y. y has an exponent that's less than 3, so we are unable to pull that out at all. So y to the third will be left inside the radical. And z to the 13th, we need to rewrite z to the 13th as z to the 12, because that's the next lowest number from 13 that's divisible by 4, and z to the first. So 12 divided by 4 is 3, so it's going to be z to the third. And left in our fourth root, all the x's are out. We left y to the third in there because 3 was smaller than 4. And we still also have this z left because it didn't get to come out. Now I would like you to pause your video and try these 3 independent practice problems on your own. Restart for the answer. Okay, for the first one, it was the cube root of negative 27, and that equals negative 3, because negative 3 to the third power is negative 27. Remember, if it's an odd root, you can take the root of a negative number, but not if it's an even root. The second one I wrote in radical form, so it was the square root of 16 to the third. Square root of 16 is 4. 4 to the third is 64. And for this last one, I started with the 8. The cube root of 8 is 2. Then I took the cube root of x to the 6th. 6 divided by 3 is 2, so it was x squared. Next, with y to the 7th, I needed to rewrite that as y to the 6th, y to the 1st. So now I can take the cube root of y to the 6th, and I got y squared that came out front. And then y1 was just left on the inside. And z squared was also left on the inside because 2 was less than 3, so I couldn't divide it by 3.